Hi, welcome to Climate Change and Wind Engineering module. My name is Mercan. I am an associate professor at the Department of Civil and Mineral Engineering at the University of Toronto. Let's together take a look at the learning objectives of our module. In this module, we will learn to describe how wind loads are induced on structures. We will understand the importance of considering the wind loads during the design of structures from both serviceability and safety aspects. We will identify different tools that are typically used to study the aerodynamic effects of wind on structures, and we will do so by following the Davenport wind load chain. Now we are going to take a look at the Davenport wind load chain, where there are 5 links, and in this module we will look at each link in detail. Right now, I will quickly summarize the content of each link. The first link introduces the wind climate, and typically it uses historical wind measurements. In the second link, we need to account for the influence of terrain. If we are building a structure in an open terrain with smooth surface, we can see from this plot that the wind speeds are going to be higher in comparison to a rough terrain, such as a city center. So depending on the location of the structure, we need to adjust the wind speed profile to properly account for the influence of the terrain. Next, we need to look at the aerodynamic effects, which is the interaction between the wind flow and the structure. Depending on the complexity of the structure, we have different tools. We can use codes and standards, such as the National Building Code of Canada. If we are only interested in along wind direction wind loads, we can use stochastic methods. If we have access to wind tunnels and we are interested in 3-dimensional wind pressure distribution, we may perform wind tunnel testing, or we can have virtual wind tunnels using computational fluid dynamics. In the next link, we obtain the dynamic response of the structure either in frequency or time domain by analyzing the structure dynamically. And once we have the displacement, acceleration, and velocity of each floor, we can compare them against a preset criteria to see whether or not our structure is safe and serviceable. When it comes to the climate change, we still use the same loading chain. The second, third, fourth, and fifth links are the same, but the information for the first link, instead of using historical measurements, we now use climate model data. In this figure, we see climate model output for yearly maximum wind speed data from 1950s until the end of the century. We perform statistical downscaling and bias correction, and after we have the corrected yearly maximum wind speed data, we can use extreme value theorem to estimate the future design wind speed, and we can take that information and propagate it through the Davenport wind load chain as described before. Starting from Bernoulli's principle, we will learn about flow-induced loads on structures in the next section, and I look forward to guiding you through the remainder of this module.